Everyone, this is Jogendra. So today we are going to introduce our model, which is automatic plant watering system, and this is built of this soil moisture sensor, this Arduino, and this submersible pump, and an Android mobile app. And the system is designed to automatically water plants based on the moisture in the soil. And when needed, you can also control the system manually using your mobile phones. Let's dive in.
Hello everyone, this is Vishal. Now let's dive into the components we are using for building this system. So we are using an Arduino Uno, which is the brain of the system, a soil moisture sensor, a relay module that controls the submersible pump, and obviously a submersible pump, an LCD display for showcasing the real-time moisture value, and a Bluetooth module for controlling the pump manually. The soil moisture sensor is the most important component we are using in our prototype. It monitors the real-time soil moisture present in the soil, and it is always inserted into the soil. So it measures the soil moisture by the resistance between the two probes present here. And if the soil is wet, the resistance is low, and if the soil is dry, the resistance is high. The information collected by the soil moisture sensor is then converted into an analog signal and is fed into Arduino Uno. The Arduino Uno reads the signal into a numerical value, where higher values indicate dryness and lower values indicate wetness present in the soil. After reading the analog value that came through from the sensor, if the value is below a set threshold value, the Arduino will send a digital low to a relay module, which makes the pump turn off, so the soil is meant to be wet. But if the value is above a threshold set value, the soil is meant to be dry, and the Arduino will send a digital high to the relay module, which makes the submersible pump turn on. So when the pump is turned on and the water is pumping, the soil moisture level automatically rises. And when it reaches a certain threshold level, the Arduino will again send a digital low to the relay module to turn on the pump. So this stops the irrigation, and the moisture level is like that continuously regulated at a particular threshold level set. Now let's look at the demonstration of our project. Now the soil moisture sensor is in the full moisture soil, so the moisture in the soil is very high, so the pump is currently now not working. Now if I remove this and keep it in a dry soil, as you can see, the pump started working. So now in our project we have also added a manual override mode that takes input from an app developed by MIT App Inventor and turns the pump on or off based on our wish. So when we click the pump on button, it sends a signal 1 that is high to a Bluetooth, that then Arduino processes that and sends a high to the relay module that turns the pump on. And similarly, if you send a 0, the pump turns off. Like this, you can also manually override the auto mode and give water to your plants on your.
We have also developed an Android online application to control the flow of water manually. Like if some crops need more water, so we want to add more water according to our crop, then we can also on the pump manually. You can see there's enough water in our crop, but some crops need more water. So if I want to add more water according to my choice, according to my crop need, then I can also turn the pump manually. This will not consider the moisture according to the sensor. This will only work according to my command. If I'll turn on the pump, it will work in on condition, and if I want to turn it off manually, then I can also turn it off. So that's how we can also control the flow of water manually according to our crop, according to our choice, and according to the need of water.